Today's Zoom session is brought to you by the fractals fire and water. All right, for today, we're finishing chapter 5, and we'll be beginning chapter 6. Chapter 5, we talk about solving equations, quadratic equations over a few cubics, by factoring. The rule is what's called the zero factors rule. If you have an expression that's factored, in other words, become a product, and that factored expression equals 0, then one of the factors must be 0. If a times b is 0, then a equals 0 or b equals 0. And then if these can be solved, then you've solved this equation. So for example, x times x minus 1 equals 0. Well, one of these factors must be 0. Either x is 0 or x minus 1 is 0. So either x is 0 or x equals 1. There you go. Here we have it's not in the right form where expression equals 0, so we turn it into that. 2x squared equals 3x. First thing we do is subtract 3x from both sides and get 2x squared minus 3x. That equals 0. Now this we can factor. Pull out a factor of x times 2x minus 3. So x times 2x minus 3 is 0. Therefore, either x is 0 or 2x minus 3 is 0. So x is 0, or from here we transpose the 3 and the 2 and get x is 3/2. Here we have x squared minus 7x plus 12 equals 0. We have it in the form of expression equals 0, but we need to factor this. Okay, this is a quadratic. We need two numbers p and q whose sum is the middle coefficient, -7, and whose product is 12. -3 and -4 work, so this factors into x minus 3 times x minus 4 equals 0. Therefore, x minus 3 is 0, or x minus 4 is 0. From here, x is 3, or from here, x is 4. X is 3 or 4. Two solutions. Here we have 3m squared plus 10m plus 3 equals 0. Okay, this will require factoring, and it will require the AC method because we have a 3 instead of a 1 in front of the m squared. So we need two numbers p and q. Their sum must be the middle coefficient 10, and their product must be a times c. That's 3 times 3 is 9. Sum is 10, product is 9, 1 and 9 work. So what we do is we'll break this 10m into m plus 9m, and this should factor by grouping. 3m squared plus m is a common factor of m times 3m plus 1. 9m plus 3 is a common factor of 3 times also 3m plus 1, and this should be a 3m here. And so I'm going to have to change that in Canvas. Not 5, 9, 2, 3m plus 1. Okay, well, anyhow, so common factor of 3m plus 1, sorry about this, times an m plus 3. So m plus 3 times 3m plus 1 is 0. So m plus 3 is 0, or 3m plus 1 is 0. From here, m is -3. From here, we transpose the 1 and divide by 3. M is -1/3. So -3 and -1/3 are the solutions of this. Okay. Here we have some examples. Z squared plus 8z plus 15 equals 0. We need two numbers whose sum is 8 and whose product is 15. 3 and 5 work. So this factors into x, z plus 3 times z plus 5 is 0. Therefore, z plus 3 is 0, or z plus 5 is 0. This solves the z equals -3, and this solves the z equals -5. So those are the solutions of this. 2x squared minus 3x plus 1 is 0. Well, okay. AC method is required. P and Q must be the middle coefficient, -3. And P times Q is 2 times 1 is a 2. So two numbers whose sum is -3 and whose product is 2. If you go through a list of possibles, -1 by -2 work fine. So, right, -3x as -2x minus x. So these two terms have a common factor of 2x times x minus 1. This is minus x plus 1. That's the opposite of x minus 1. So write that. Common factor of x minus 1 comes out times 2x minus 1. That product is 0. So 2x minus 1 is 0, or x minus 1 is 0. And from here, 2x minus 1 is 0. You add 1, divide by 2. X is 1/2. Here you add 1. X is 1. So 1/2 or 1 solves this equation. X squared plus x equals 0. It's pretty easy. Common factor of x times x plus 1 equals 0. So either x is 0 or x plus 1 is 0. So it means x is 0 or negative 1. It's pretty easy. 16y squared minus equals 9. Well, okay, subtract 9. 16y squared minus 9 equals 0. Now this is a difference of squares. 16y squared is the square of 4x. 9 is the square of 3. This is a difference of squares equaling 0. And a difference of squares equals a difference times the sum. 4x minus 3 times 4x plus 3, the product equals 0. So either 4x minus 3 is 0 or 4x plus 3 is 0. And by adding or subtracting a 3 and then dividing by a 4, you get x is 3/4 or x is negative 3/4. These are the two solutions here. Oh, and by the way, this business where difference of squares means that x is plus or minus something else, we'll be seeing that a lot later on. It's part of a general way of solving quadratic equations. Here we have 3a squared over 2 equals 1/2 minus a. Well, these 2's are annoying, so we multiply throughout by 2. We'll get 3a squared equals 1 minus 2a. And after some transposing, 3a squared plus 2a minus 1 equals 0. All right, so now we need to factor this by the AC method. We need P and Q whose sum is 2, and whose product is 3 times negative 1, that's negative 3. And 3 and negative 1 work. These sum to 2, these multiply to negative 3. So I'll write this 2a as 3a minus a. 3a squared plus 3a minus a minus 1 equals 0. These have a common these two terms have a common factor of 3a times an a plus 1. Minus a minus 1, we'll pull out a negative 1 times also a plus 1. Okay, remove a common factor of a plus 1 times 3a minus 1. That equals 0. So one of these two factors is 0. 3a minus 1 is 0, or a plus 1 is 0. For this one, add 1 to both sides, divide both sides by 3, get a equals 1/3. Or here we just transpose the 1 and get a equals negative 1. Solutions are 1/3 or negative 1. This is another messy one. 8/3 a squared equals 1 minus 10/3 a. Again, these annoying 3's, we'll get rid of them by multiplying throughout by 3. Look at 8a squared equals 1 times 3 is 3 minus 10/3 times 3 is 10a. Okay, transpose the 10a and the 3, get 8a squared plus 10a minus 3 equals 0. Now to factor this, we'll need P and Q whose sum is 10 here. Whose product is 8 times negative 3. It's negative 24. And okay, here I actually go to the trouble of actually searching. Whatever P is, Q is negative 24 over P, and we look for the sum. P is 1, Q is negative 24. The sum is negative 23, which is the wrong size and the wrong sign. Negative 1, positive 24, positive 23, still too big. Negative 2, positive 12, sum is 10 as required, so there we go. Negative 2 and 10. So I'll write this 10a as minus 2a plus 12a from here. And this should factor by grouping. 8a squared minus 2a, common factor of 2a, times a 4a minus 1. 12a minus 3, common factor of 3, times a 4a minus 1. Remove the 4a minus 1, there it is, times 2a plus 3, there that is. Product equals 0, so 2a plus 3 is 0, or 4a minus 1 is 0. A bit of transposing, a bit of dividing. A is negative 3/2, or a is 1/4. These solve that. Here we have something I call breaking a vase in order to glue it back together again. B times 6b minus 7 equals 10. If this were a 0 on this side, we could pretty easily solve it. B is 10 or B is 7/6. But here's this 10. So what we have to do is distribute this, then transpose the 10. So distribute 6b squared minus 7b equals 10. And subtract 10. 6b squared minus 7b minus 10 equals 0. Now this is the shattered vase, which we must glue back together again. We need P and Q, whose sum is a -7 here. And their product is 6 times -10, which is -60. So we'll search among the factors of -60 for 2, which add up to -7. Whatever P is, Q is -60 over P, and we look for the right sum. 1, -60 for Q, sum is -59. Too big. 2, -30, -28. Not yet. 3, -20, -17. Still not there. 4, -60 over 4 is -15. Their sum is -11. It's getting close. If P is 5, -60 over 5 is -12. Sum is -7 as required. So this -7b we can write as 5b minus 12b, which is what we do here. 6b squared plus 5b minus 12b minus 10 equals 0. These two terms, 6b squared plus 5b, have a common factor of b times the 6b plus 5. Minus 12b minus 10 have a common factor of -2 times, again, 6b plus 5. Remove the 6b plus 5 times a b minus 2. That product equals 0. This factor is 0, or this factor is 0. B minus 2 is 0, or 6b minus 5 is 0. Here 6b is -5, and b is -5/6, or b is 2. So these solve that. Okay, good. We're finished with this section. Let's stop the recording for here.